This is the third of the four function transformation videos in this seminar. So just like in the previous video, I want you to open GeoGebra and then graph these functions and then think about their relationships and also try to answer the questions here. So you can pause the video now and then we will discuss. Okay, so let's try graphing first f of x equals x cubed minus 4x. So f of x equals x cubed minus 4x. And then the second function is g of x equals 2 times quantity x cubed minus 4x. Now, if you look at the points one by one, it will make sense why the graph looks like this. So for example, since we multiply the output, which is x cubed minus 4x by 2, of course, in effect, we are multiplying the y-coordinates of the points by 2. So for example, here, the value of f here is equal to 3. And if we multiply by 2, it becomes 6. And this is the same here. For example, at x equals 1, the value of f is negative 3. And therefore, if you multiply it by 2, then the value of g here is x equals, or is y equals negative 6. So that's the value of the function. Now what is happening in the intersection? Why do the graphs intersect? If you think about it, the value of f here is 0. So the y value of the function is 0. And meaning, it means that the value here is 0. So if you multiply 0 by 2, then it is also equal to 0. That's why the value of g here is also 0. That's why the two graphs intersect at x equals 0. Now, if you look at h here, the analogy is very similar to g. So I will leave that to you. But we will graph j of x equals 0.5 times x cubed minus 4x. So let's graph that. J of x equals 0.5 times x cubed minus 4x. So how is it different from f? If you multiply the output by 0.5, of course, the value of the y-coordinates of the graph, or of the points on the graph, is also multiplied by 0.5. So here at y equals 3, if you multiply by 0.5, of course, the value is half of 3, which is 1.5. And this is also similar here. And in the same way, if you multiply 0.5 by 0, which is the value of f here, then the product is also 0. That's why the graph of j also passes through x equals 0. So, meaning if you multiply the output of a function by a number greater than 1, for example, if for a larger number, it will stretch the graph vertically. And if you multiply the output by a number less than 1, then it will shrink the graph vertically. So to summarize, multiplying the outputs by a number greater than 1 will stretch the graph vertically. So as you can see, the graph looks steeper here. And multiplying the outputs by a number between 0 and 1 will shrink the graph vertically. The graph will look flatter. So what I want you to think about is, what if you multiply the outputs by a number less than 0? So what do you think will be the appearance of this graph? So that's for you to explore.